Hi guys, we are going to work a little bit on determining a molecular formula. In the previous video and lesson, we worked on determining an empirical formula. So this one's just the next step, and you're going to see us review the empirical formula one in just a little bit. So let's go over some basics of what you need, what information that you need in order to determine the molecular formula of a compound. So in this first one, it says, what is the molecular compound that has an empirical formula of CFBrO? And it has a molar mass of 254.7 grams per mole. So this is the molar mass of your unknown molecular formula. Okay, and then here's its empirical formula. And those are usually the two pieces of information you'll either be given, or you will, at times, like you'll see in a little bit, have to find this on your own. And then using that molar mass of that unknown molecular formula, you're going to have to then use those together to figure out the answer here. So the first step is to see what is the mass of this empirical formula. So I'm going to come over here, and using my periodic table for masses, I'm going to add up a carbon, fluorine, bromine, and oxygen. And when you add that up, the molar mass of the empirical is 126.91 grams per mole. We want to know how much bigger the molecular formula is. So these two masses should be essentially equal to each other, 1-to-1, or the actual molecular compound should be larger than its empirical. So either way, you're always going to start with your molecular formula up in the numerator. I'm going to divide that by the mass I just found, and when you plug that in, okay, you should get something very close to a whole number, in this case 2. So that means that molecular formula is 2 times bigger than the empirical. Remember, empirical is just the simplest ratio. So we're basically working backwards to find what the original formula was. So this would be written as C2F2Br2O2. And it's critical that you're multiplying all the subscripts by that number. It would be completely incorrect to write it out like this. Okay, you're saying you have 2 molecules of this. That's not what we want. Okay, we want to show that this is the actual formula of that molecule and how it exists. Okay, all right, so let's apply this to a question that you're more likely going to see, where you're going to find the empirical formula first, and then using that, find the molecular formula. So this is going to essentially be a review of our previous lesson, but it's good practice. So with this one, we're given our percent compositions. So we're going to find how many moles of carbon and hydrogen I have, and then get them into the whole number ratio. So we're going to have carbon. I'm going to assume I have 100 grams. So 82.8% of that would be 82.8 grams. And then hydrogen is going to be 17.2 grams. I'm going to use each of their molar masses. So for carbon, that's 12.01 off our AP reference tables. And for hydrogen is 1.008 with our 1 mole there. Okay. When you go and divide those and keeping to the 3 sig figs, I get 6.89 moles of carbon for every 17.1 mole of hydrogen. So just like our previous process that we talked about, we're going to just simply get these into whole numbers by dividing them by the smallest amount of moles. That allows us to set carbon to 1. Hydrogen here, you're going to get 2.5. Which is important because we're still not in whole numbers. So in order to rectify that, we're going to multiply all the moles by 2, which gives us 2 moles of carbon for every 5 moles of hydrogen, which leads us to our empirical formula, which will be C2H5. Okay, in part B here, we're going to take that empirical formula, and now we need to find the molecular formula. So just like in example 1, I'm going to take C2H5. I'm going to find its molar mass. So I'm adding up the 2 carbons, my 5 hydrogens, and I'm going to get to the 100th spot, 29.6 grams per mole. Okay. Now we're going to take that molar mass of our unknown formula, 58, divide it by our molar mass of our empirical, and you get essentially 2 here. That's close enough that we can round that acceptably to 2. So that means my molecular formula is 2 times larger, which means I need to multiply all the subscripts by 2, which then will lead us to C4H10. One way to also check that is if you actually add up the molar mass of this, you should get 58. So that's one way to just do a double check of your work. Okay, so that's just adding on again to our previous lesson on determining the empirical formula. In this one, we simply use the molar mass of the molecular formula along with its empirical formula to find our molecular formula.